Electric field inside a uniformly charged solid sphere of non-conducting material. Okay, so it's a non-conductor. It means what the thing you are seeing here, it is a uniformly charged solid sphere of non-conducting material whose radius is r. Right? Let me say the radius of this material is r. That is radius. Right? Radius is equals r. Radius is r. Charge density. Okay, so volume charge density. Volume charge density. Volume charge density is rho. Okay, so now what we have to find? We have to find electric field at a point inside this sphere. Yeah, we have to believe electric charge is distributed inside uniformly. Okay, so electric field is distributed uniformly inside this sphere everywhere, right? So everywhere there are charges inside this sphere. This is what we are seeing. Okay, so uniformly the charges are distributed, and this is the center O. Now I'm drawing such a line which is representing normal to the surface. Okay, and now if I write some point somewhere here. Okay, so this point, say it is some P. Electric field at this point depends on the distance from the center. Right, if I say this distance OP is x. Okay, so OP is x. Then electric field at P will be in this direction. Right, and EP, the electric field EP is given by, how actually we write it? It is nothing but 1 by 4 pi epsilon O. Right, the complete charge on the sphere, if it is Q, divided by the square of the distance. Otherwise, I use the volume charge density term here. See how I can make use. For Q, I can write, density, charge density is nothing but Q divided by the volume of the sphere 4 by 3 pi r cube. What I can write for Q? So, which implies Q is equals, right? Q is equals 4 by 3 pi, right? 4 by 3 pi. It is rho r cube, right? So when I use this one in this particular equation, what I can write for EP? Therefore EP is equals 1 by 4 pi epsilon O, right? What I can write for Q? Q is 4 by 3 pi rho r cube, right? So I can rewrite this equation. Now 4 pi and 4 pi get cancelled. The terms which are left are rho r cube, and in the denominator it is 3 epsilon O x square. This is how we can rewrite the electric field at any point P, which is outside. Right, here what is x? X is greater than r. So point P is lying outside the sphere. Well, otherwise one more variety we can make use here, this one. Instead of writing this 1 by 4 pi epsilon O, okay, if 1 by 4 pi epsilon O is termed as K, then EP is nothing but K into Q divided by x square. This also be written. Okay, so in terms of Q and in terms of rho. Now what I have to think is, I have to notify such a point which is lying at the surface. If I call a point somewhere here, it is, say it's A, right? So at point A, what should be the electric field? So electric field at this point is this one. This is EA, the electric field which is acting outside. Now how we can write EA? EA can be written like this, right? EA is equal to, in the same way I can rewrite it. It is rho r cube divided by 3 epsilon O, and here I put x is equals r. Okay, so this becomes r square. That means EA is equal to rho r divided by 3 epsilon O. This is the way how I can write. This is at the surface. At the surface. And this is outside the surface. Okay. Now we have to put our concentration on a point which is lying inside. What I do for that, I am simply drawing a point somewhere here, okay, and this point is B. Point is B. And at B, if you analyze, if the distance between this O and B is again something say R, which is the distance from O to B, right? So O to B here. The radius of the complete sphere is R, capital letter R, and the distance from center to the point B which is lying inside is small letter r. Okay, so OB is R. Be careful. Now at B, the electric field will act in opposite direction to this one, this O. That means it is directed away from the center, this direction. Okay, and this electric field is I am calling EB. EB is the inside electric field which is acting here along the radial vector, this one. Okay, so now what I do here is I am simply making an analysis that showing you a small circle, I mean sphere inside this charged sphere, right? This one, what you are seeing here, the dotted thing I wrote on, and this one is nothing but an imaginary sphere drawn inside. Now if I redraw that one, right here like this, this one, this is the center O, and here exists the point B, and this distance is R. The electric field at B is acting in this direction. This is EB, what I already shown here. And what are the things that left? You can simply imagine the remaining portion outside this sphere is this much, right? So this one, what I can write like this, like this. Okay, so this is a solid body and this is also a solid body. This is the remaining part, and where is B now? So point B is here. This is point B and this is point O. Okay, so what we are seeing now, this part should be removed. Okay, so this is the thing we are removing from this. The outer rim we are removing, only the middle portion will remain like this. Okay, so in this key point, what happens? This is the sphere. Okay, this is the shell, a thick shell. Point B is existing here at the outer edge of the sphere and inner edge of the shell, right? So electric field at B, is equals, okay, electric field due to the sphere plus electric field due to the shell. This is our assumption. But one thing you must know. Here, what we are seeing, the charges are distributed inside like this. The charges are distributed like this. Right. And here, the charges are distributed here in the shell. Okay. So, no charge is existing inside. Right. Therefore, electric field at B, okay, electric field at B is 0. Okay. B is a point inside. Electric field at B due to the shell is 0. This one is 0. Okay. Is equal to 0. Equal to 0. And what is this? This is just like the electric field at the surface of a charged sphere. That is what we already did. That is this point, right? This one. But it is did for the complete sphere, which is big sphere. Now we are talking about the inner one. That means for this, what I can write? For this, we can easily write in this manner. Rho. R stands for radius of the sphere. The radius of the sphere is R. Right, for this one. Therefore, I should write R. And in the denominator, nothing. It is 3 epsilon O. Therefore, what I can write? This is EB is equals rho R divided by 3 epsilon O plus 0. Because shell contributes nothing. No electric field at B. Therefore, only this much. So, which implies what I got? EB is equal to rho into R divided by 3 epsilon O. This is the expression for the electric field at any point, right? At any point lying inside the charged sphere. This one, which is lying inside the sphere, right? So, having said this, we completed the notation. But one thing you must observe, inside the electric field, right, is proportional to the distance, right, where R is less than R. So, for such a kind of one charged body, the point which is lying inside this, the electric field intensity versus distance. So, this is a point where we reach the surface, right? This is outside and this is inside. When we start from the center and we reach the maximum at the surface, okay, this will be, the maximum will be this much. And inside we are having this relation, right? For that, we should note one thing. This is Emax, which is given by this equation. Okay, this equation, which is EA here. So, the curve, the graph curve will go like this. This is a straight line inside. Okay, so this is inside. And this is inside, right? And as we move away from the surface outwards, say at any point P, we will follow this equation. Here it is, rho R cube divided by 3 epsilon O is a constant and 1 divided by x square. So, that means it is exponentially decreasing function, right? This is outside. And this point is maximum at surface.